My name is Michele Sciolette. I'm the head of visual effects technology at Cinesite, and I'm going to talk to you a little bit about the work we've done recently to improve our pipeline. So, first of all, who's Cinesite? Cinesite is a visual effects house based in Soho in London. We employ anything between 150 to 400 artists, depending on production. Over nearly 20 years of career in this industry, we've been working on some of the major blockbusters, from the Harry Potter franchises to the Pirates of the Caribbean, Bond movies, all the way to smaller independent productions such as Moon and award-winning television shows such as Rome and Generation Kill. More recently, we've developed a large part of the visual effects work on Paramount's World War Z, and this is a small sample of the work we've done there.
Remain with your feet!
Okay, so I'm going to talk a little bit about what I consider one of the challenges we have today in visual effects. We have all these fantastic software providers like the Foundry giving us access to amazing tools, and this combined with these fantastic talented artists that we have today gives us a fantastic infrastructure. And from that point of view, it feels like all the creative problems can be solved. What is challenging today is more and more how to manage that creative process in under a very tight schedule that gets shorter and shorter with every production, and in a very competitive market. So what we need is to have a framework that allows us to put all these artists using different tools in an environment that allows them to collaborate efficiently. And more importantly, we need a framework that can be easily adapted to the requirements of each individual production. So last year, we were here at SIGGRAPH presenting the work we've done on John Carter. It was by far the biggest project Cinesite has ever done. We were delivering over 800 very complex visual effects shots and over 1,500 shots of stereoscopic conversion. To track and manage that project, we relied on our proprietary asset tracking and project tracking system. This was a big success for us, our system delivered a very stable infrastructure to manage the project. But at the end, we identified a few areas where we felt we really could improve the system. In particular, we found that it was a bit too hard to introduce new steps in our workflow. That became obvious in particular with the stereoscopic conversion. In our traditional workflow, we had compositing as the last step of the pipeline. With the stereoscopic conversion, we had to introduce a few additional steps, such as dialing the stereoscopic camera, producing right eye renders of our CG components, and all the way to the stereoscopic full conversion. We find it was a bit difficult for us to adapt the workflow to include those additional steps. In addition to that, we had slight differences across different departments, such as the way we handle data in 2D was slightly different from some of the data wrangling we had in the 3D department. We also had bespoke asset management tools for each application. So the way we loaded, for instance, a camera in Maya was different from the way we loaded a camera in NUKE. That had the potential to provide inconsistent results in some cases. In addition to that, we had different tracking systems. So we had an asset tracking system used by artists, but we also had some additional production tracking system used only by producers. So at the end of the project, we felt it was the right time for us to really think about what we would like from as an ideal system. So the key challenge here is to find the perfect balance between having a nice structured workflow and framework and having the flexibility to adapt to any new requests that may come up. So we set on a few key design principles. In particular, we started saying that we wanted absolutely anything done by any artist at the company to be encapsulated in a task. So a task would incorporate all the information such as who's doing the work, when is it needed by, what type of work it is, and so on. This having everything done and tracked consistently within a task gives us a good structure. We also said absolutely anything produced by any artist would be encapsulated in an asset version. No matter what type of data it is, it could be a photographer going on set and capturing a set of stills. When they come back to the company, they would produce a version of a stills collection asset. All the way to compositors obviously publishing their work as a compositing asset, and the same for animation and so forth. This also helps to give us some solid structure. Finally, all tasks and assets would behave consistently so that we would have this underlying standard workflow in terms of approval, in terms of tracking, in terms of versioning. On the other side, we want to be able to support any type of tasks. We really want to have a system where if a new workflow is needed, we can easily create a new type of tasks, slot it in the system, and know that everything else would behave consistently. Equally, we want to support any type of assets. As I mentioned, anything from stills collections to all the more traditional artist outputs. And this functionality would allow us to create any type of workflow, simply recombining different tasks for what is needed by the specific production. Another key principle was that we wanted to make sure that the way we handled assets would be using the exact same code across all applications. We didn't simply want to use the same logic, but we wanted to make sure we had absolutely the same lines of code being used in NUKE, Mari, Maya, and so forth, in any application we would support. This has the huge benefit of, first of all, completely eliminating any concerns about two softwares providing different results when we ask, for instance, for the right camera for my shot. But even more has the added benefit of minimizing our maintenance efforts. So we can basically maintain only one set of asset loaders. So about a year ago, we were still thinking about whether we should continue maintaining our own proprietary system or look at commercial products. We wrote a specification document highlighting everything we need from our system. And the result all the way down to some Python sample code to give us a feel for how we wanted the system to behave. The outcome was that we wanted a system that had very strong native support for tasks and assets, a solid backend database that could be easily customized according to the specific requirement for each show, and a comprehensive and easy-to-use Python API. In addition to that, we wanted a customizable and easy-to-use web interface to allow all users to access the data. So in spring 2012, we had a sneak peek at a new upcoming product called FTRACK, and we felt that it fit perfectly with all our key requests. So about a year ago, we decided to embrace FTRACK as the underlying system for our production tracking and asset tracking. At this point, we made our mind. We knew we wanted FTRACK to be the underlying structure, and we wanted to have all our applications to talk directly to FTRACK. But what we didn't want is have a straight connection from each individual application into the FTRACK database. So we decided to introduce an additional layer that we called application abstract interface that would allow us to transfer all the information within from FTRACK to the application going through a common interface. So by doing that, all the functionality such as loading assets, managing versions within the application would be 100% consistent. So the only thing each application would need to develop in order to be part of our workflow is simply define what type of data it would understand. For instance, NUKE would declare simply, I understand image sequences, cameras, geometry, for instance. How to import new versions. Again, NUKE would simply say, I need to create a read node pointing to this path in order to load an image sequence. How to list all the versions that are loaded within the current project, and how to find dependencies. By doing that, we would automatically have available in the application a fully fledged asset loading system, a version manager, and an infrastructure to publish our data. Okay, finally, around October 2012, we have been awarded the stereoscopic conversion of over 400 shots for World War Z. And this came just 5 months after we made the decision to embrace FTRACK in production. And our conversion workflow is heavily NUKE-centric. So we felt it would be the perfect opportunity for us to test our new workflow in production. This is our application start. It has all the functionality to list all the tasks assigned to the artist. All this information is sourced directly from FTRACK. And it has got a list of applications that the artist may want to run and all the additional options to choose which version of the pipeline to be picked up, if not the default one. In this case, I'm using start to, I select a particular task assigned to me, and I'm choosing to fire up NUKE. The first thing we see when we get into NUKE is our asset loader. This has got all the functionality needed to choose which assets are available for my shot, for my task, and I have all the basic functionality to filter what type of assets I want to load based on type and name and so forth. Once I choose a task, I have all the functionality to select a particular version, saying all approval status, publication comments, and any additional notes. In this case, I'm loading a few of the key ingredients that are required for our stereoscopic conversion workflow. In particular, I'm loading the plate to be converted. I'm loading a camera that I need for my shot. And our stereoscopic conversion workflow relies heavily on having accurate 3D geometry. So in addition to the camera, we have what we call rotomation, which is detailed animated geometry representing all the key objects in my scene. And finally, we use extensive 2D rotoscope, traditional rotos, to have edge-accurate segmentation of the different components of the image. So here I've used our asset loader to load all of these components in my shot. But because of the specific stereoscopic conversion structure, we can also do something more advanced. In this case, we developed a auto layout tool, as we call it, which allows us to, in one go, detect all the approved version that should be used in the stereoscopic conversion process. So in this case, I can see that the auto layout tool is finding all the latest approved version for my camera, my plate, my rotomation, and my roto, and provides me a view on how this whole hierarchy of detailed information has been produced in the previous steps, and I can decide here to which level of aggregation I want to collapse my structure. In this case, I'm simply choosing to load a foreground, a midground, and a background structure. Here, the tool is now matching all the pieces of 2D rotoscoping to the corresponding rotomation geometry, and provides me with a predefined 3D structure where I can see that all the 2D rotos are correctly linked to the geometry, and everything is aggregated according to my specified foreground, midground, and background. All of this is fed through our image processing part of the conversion and finally merged together to provide the final result. Here we jump ahead a little bit in the process, going all the way to the compositing task. So I'm using our asset loader to load a later version of the compositing output. I'm loading the composite script, and I can switch to the version manager part of our pipeline, which is again common across all applications and provides us a list of all the assets that I have currently in my project, and provides me a clear indication of whether they are actually the latest approved version or not. In this case, I can see that one of my element, in particular the background plate, is not up to date, and I can easily update it to the latest version. Finally, now that my script is all up to date, I can go ahead and publish my final result. I have access to a standard publication interface. Again, this is common across all our applications. What I see here is I'm going to publish a compositing output, which is made out of two components, a set of frames and a NUKE script that are bundled together in one version. And I can see that I have a set of dependencies, which are all the elements I'm using in my comp, and they're all approved in this case. I can just go ahead, add a comment, and publish. Once the publication has been complete, I can go back into FTRACK and take a look at my latest publication, review any quick times of the version, add additional notes, and approve the element if it is a valid comp. This is an overview of the tools we had during the stereoscopic conversion. And the artist feedback has been very positive, ranging from all working well, no problem, to I love the pipeline, the only complaint is too easy, to I always have FTRACK open, I like the colors. That was one of the feedback we got. And spreadsheets are no longer allowed in my team. Again, we had in particular, some of our leads heavily relied on having spreadsheets where they like to keep track of all the details of who was doing what, in addition to our existing system. And luckily, we found that they felt that they absolutely had no need for that. Where are we now? So since finishing the stereoscopic conversion, we've moved all of our visual effects production to this new pipeline, and we are currently in production with two projects, Warner's The Edge of Tomorrow, starting Tom Cruise, and The Monuments Men, directed by George Clooney. So in order to allow us to have a fully implemented visual effects workflow, we needed to extend our application interface to more applications. So now we support absolutely all the tools required by our workflow. A key aspect here is having Python support within the application really makes it extremely easy for us to integrate our tools. So this is an example how the same tools look and feel in Mari, for instance. So here we see the user using our standard asset loader to we are using Start to fire up Mari. And within Mari, we have access to our default asset loader. And in this case, I'm loading some geometry that I need in my scene. In this case, I have an additional widget that allows me to choose what kind of UV tiles I want to load for my object. I then use the same loader to load the camera for my shot. And again, the key here is having this standardized workflow across all applications. In this case, the camera brings in also the background image plane, which is attached as a dependency in our asset tracking system to the camera. I load some texture for my geometry. And finally, I'm going to load some additional geometry that is needed in my scene. All of this, it provides the key ingredients for my work in Mari. And as an example, I could go ahead and start painting scratches on the texture for this truck as it hits and collides with the cars in the scene. I can then go ahead and publish my texture. And again, here the key is having this standard workflow across all applications. The same here is in Hero Player. Again, with a very small amount of coding, we managed to have all of the same tool implemented in Hero Player. Again, basic functionality, load all the image sequences produced in our company. Instead of browsing for any elements, I see this standard loader. And I have, in this case, I'm just loading a sample clip. And I have our version manager, again, available there and to manage all the versioning of elements in my timeline. Okay, so again, where are we now? The other key areas we have worked on is extending the support for different asset types. Beyond all the basic standard ones, such as compositing, animation, cameras, and so on, a good example of is editorial workflow. Editorial plays an absolutely key role in visual effects. In our previous system, as much as editors would publish to our system any new versions of the cut, as in an image sequence that was used as a reference, we didn't have the notion of actually publishing some data structure to represent how this whole cut fits together according to our shots. So in this case, just like we see any other tasks and versions available in FTRACK, we decided to add additional tasks that we would use to track the editorial work and have a new asset type called the editorial sequence in our case, which represents all the information needed to put together our shots in a single timeline. What we publish here as to represent this data is an XML file which contains all the cut information. What this allows us to do is, as the editor publishes a new version of the cut, and the cut gets approved in FTRACK, this will trigger an automated process that will update all the shot information for every shot in FTRACK and attach key metadata to each shot so that each shot will know which cuts it belongs to. So a shot can easily say to ask our database, what cuts am I into? And the result might be you are in the main cut or in the trailer, first trailer cut and second trailer and so forth. This allows us, for instance, in Hero Player to have the basic functionality to load the cut for my shot. Again, something simple, but extremely important. And what this does is it uses this latest approved editorial information to detect the cut for my shot. This is just a simple example of the workflow we can easily create. And what we see here is once I've loaded my cut, I'm presenting with a timeline where we have at the very bottom the original editorial data as provided by our clients, and stacked upon it all the different assets belonging to different tasks, such as the basic plates loaded, all directly stacked and conformed to match the initial editorial data, all the way up to the final compositing output. This is just a starting point. We definitely are going to build additional utilities based on this infrastructure. That's all I have to say today. A big thanks to the Foundry and FTRACK, and particularly a huge thank to the Cinesite development team, who's done a fantastic job to put all of this together under a short time. Thank you.